Hello guys, right, amines, amides, nitriles. I just want to finish this off with you A2 students, and I don't know, but it gives you something now. You must do the paper before you look at this video. You must do that, it's very important. Okay, so you have a good go at these properly, and don't bother asking me or emailing me about this, that and the other. You're wasting your time. I have no idea about what's happening, nor anybody else. So just chill and just learn some chemistry if you're bored. Alright, amines, amides, nitriles, there it is. Right, this is a bit of a beast, and I've been told to keep these quite short because apparently I'll be too boring otherwise, even more boring than normal. I've got to pretend you're all here as well, which is a bit tricky. So you put your mobile phone away, okay, and concentrate. Wake up a little bit, alright? And sort yourselves out. Here we go. I'm going to go through this quite quickly because otherwise it'll be boring for you. Okay, but if there's anything I can see or do, that'll be fine. Right. Okay, like I say, a long old paper. So, step 1, step 2, there you go, HCN. We know what's going to happen here. We're talking nucleophilic attack, nucleophilic addition. That'll go into there, that'll break off, right? It's creating, creating the nitrile. Bangs that in there, that breaks to there. That nitrile group, we all know that. Treat it with a bit of acid, breaks down into carboxylic acid. Shouldn't be a problem. Okay? As it says, aqueous acid. There's some bond angles for you. We've done these before, really, but okay. This one to do with the mechanism, if you recall. Again, you've got to learn all this sort of stuff, but bangs into there, that bangs to there. That intermediate is the guide, or should I say that what happens here is dictated by what I end up with here. Okay, so that goes to there, that breaks to there, and then I need to re-establish that double bond, so it's got to go in there, and that's broken off. To there, gaining a lone pair, job done. Straightforward, we've met it before. There's a lot of these. Okay, a lot in this. Okay, yeah, this one, methyl lactate, ethanoyl chloride and acyl chloride. Now, you know what these react with. Sure, they can react with water to form the carboxylic acid. That's absolutely fine. Or they can react with ammonia, or they can react, of course, with an amine or an alcohol to make high-yield esters or amides. We are aware of that. They don't react with esters. That's there to mess you about. They react with alcohols. So we bangs that on. Ester link, job done. What's missing as the byproduct there? I want an answer. HCl. We know this. It's eliminated out of the molecule. Next. This is a good one. Covers a lot of ground. I'll try and fit it on as much as I can. Right. Hopefully you'll be able to see it all right. There you go, reaction 1, HBr, straight across the double bond. Yeah, but which side does the H go? Which side does the Br go? We don't know. Is there a clue somewhere? I've got to scroll down. Oh, right, well if I go all the way down to here, I've got an OH on here from somewhere. So if I put my Br there and my H there, HBr across there, I can play with it. So, that is informed by that actually. Right, anyway, down there, so I take that, nucleophilic substitution. Have I made a mistake here? Salt, okay, knocks the salt back. Rubbish, that, NaOH, right, CBr, COH that should say. What a fool, right? COH there. Right, then you're away. That knocks the salt group back to its original carboxylic acid. And I can tell you what's going to happen here. Ethanolic ammonia, we've met it many a time. Again, nucleophilic, we'll attack that halo. Haloalkanes are a route to a lot of stuff, right? We'll put an amine group on there. I'll quickly flash that up for you, but you know the score. There it is, look, jobs are good. Okay, next. Mechanism that occurs in reaction 1, AS, end of. Total AS, you should be absolutely fine. Bang that to there, that breaks to there. Adds on, H adds on there. Yeah, you can't see it. That adds on to there, to the carbocation, bang. Straightforward, get rid. Okay, electrophilic addition, 4 marks, do me a favour. Anybody can do that. Next. A bit of polymerisation, that's handy for you because I don't know where I'm going to do much on this, we'll see, but polymerisation, addition, condensation, so it can carboxylic acid group OH self-polymerise with polyester groups, double bond in here, addition polymerisation, and that is what they want, addition polymerisation. There it is, straight across that double bond, never mind what's on it. That's what matters. Reduce the bits that don't to nothing. To repeat units, the condensation one. Right, I've done more than that. Now, it takes a bit of doing, that does. You need to look at that and pay a bit of attention at it. Think it's right. Ester link. Ester link. But that is a beautiful skeletal. Learn. Totally beautiful. Right, you can do that, you're on it, okay? Jobs are good, and I don't know, it says repeating unit, put some stuff around that, whatever, but that is the way, okay? Sort that. Right, chiral centres, again, and we've touched on this before, and I've taught it to you, and I've been through it. You're looking for, you're looking for 3 different, because there's a 4th, which is the H. So, that one's 4 different, bang on chiral. That one's 4 different, 1, 2, 3, 4, methyl, totally chiral. That one's got 3, but they're all different because that goes to all this goes to, there's an H on there, chiral, 3 on there, there's an H on there, chiral, 3, H, 4 on there, 1, 2, 3, 4, 5, 6 is the one, 6, C, sorted. Compound below prepared from phenol. Watch out. Watch out. You're putting an NH2 on there. Which reagents are required? Now, we know how to put an NO2 on. You can use dilute nitric acid. I'm going to use a nitrating mixture because of the phenol group on the ring, making the ring more, you know this, electron rich. Right, which reagents are required? So, I'm guessing here dilute nitric and then to put an NO2 on and then tin HCl. Hopefully I'm right, fingers crossed, otherwise I'm going to look silly to millions of people. Sweet. Next. Excess, what's the main organic? This is, you know, a bit of AS, a bit of weird stuff. Knock that out, put that on, surely. Is it that simple, eh? I reckon. Let's go. Beautiful, this paper. There's so much in it. Next. Alpha amino acids. I'm not interested in this. Your job is to draw it out. That's the R group there, isn't it? NH2CH. Yeah. There's the R group. It's bracketed, non-superimposable mirror images. Draw them out. I don't see an issue with that. Job's a good one. Okay. Serine, can react with the even acid glycine, form 3 different products. Organic products. They're going to be dipeptides. So, okay, because that's got there's going to be all sorts of combinations here. What a pain! But it's a case of working through them. I can see all sorts of potential. Okay. And there they are. This I don't like. 3 marks for quite a lot of work, right? So your serine, yeah, can react with your glycine, no problem, through the carboxylic acid of the serine and the amine of the glycine to make your amide link dipeptide sorted. Swap them around. Carboxylic acid of that, that's the amine of that. That's an N there. Amide link between the two, swapped around. But also, you've got glycine as well with a carboxylic acid, and your serine had an OH on it. You can make a beautiful ester link there. 1, 2, 3. A lot of work in that for 3 marks, but you need it, okay? And you can be fast. It's not like much difficulty. It's just a bit of a pain. Next. General structures of the aspartic acid, oh yeah, dead easy. You shouldn't have a problem with these if you know your stuff, guys, okay? So, here we are, look, draw aspartic acid, but they've told me what it looks like, haven't they, up there? Let me just check on my sheet. What page is it? Bear with me a minute. I don't Just bear with me a minute. Yeah, they said earlier what it was, so you can draw that out. It's all very clear, as I thought. It tells you what the R group is, job done. HCl, cover this up, I don't know. HCl, right, was going to salt that. Anything else? No. Okay. This looks like esterification to me. Okay. You might, because you've got acid there, it's a base, salt there, or because I've got a carboxylic there, right, which is a bit of a pain, but there's nothing to stop it esterifying through that one as well. It's all there, lovely, dead easy. Next. Yeah, I don't know what this is. Pain in the backside. Right, compound G and amino acid branched R group, that many moles of it. Right, well, what else are you supposed to do? Work out the molar mass of G. Right, 117, any four can do that. Suggested structure. Right, well, you can, okay, 117. You know it's got a carboxylic acid, you know it's got an amine, you know it's got that carbon, that's your alpha carbon, you know it's got an H, alpha amino acid. That bit there is fixed. Subtract comes to 74, that bit. Left with 43. Know from your mass spec, 43. So I think that's C3H7. But if you look A2s at my AS, I delve into this. It could also be that. For that is 43. Secondary carbocation, secondary fragment with a positive charge on it. Also, so in other words, R could be straight, R could be branched. Oh, it says it's branched. Classic. That fits very in with the AS before earlier vid. Don't know how long this has been running. Right, where are we? So, fairly quick, speeding up. Alright, guys, NABR, what's the crack here? To make that, right, well, you know this is pure AS. NABR, OH back to BR, sorted, yeah. Take that, ethanol, to turn the usual haloalkane sequence here, AS and A2, haloalkane sequence. I'll try and teach this, right? I haven't taught you anything, I've taught you all this, but nothing, right? So that goes on there, jobs are good, okay? Dead easy. I mean, this is gold for you. You better have done this before looking at it. There's so much in this, I can't tell you. Right, benzene, we know this. Oh, you're putting an acyl group here. You've just got to be careful about how many carbons. So we took that bond there, joins that carbon, C double bond O there. So there it is, look here. Yeah, so it's going to form a bond to that carbon, giving you that structure, okay? So that's cool, right? But it won't do it on its own, it needs that, it needs a halogen carrier. With straight benzene, you need halogen carrier, dead easy. Right, take that, knock it back, reduce it, because that's, well, hang on, what am I doing it? No, you're running the game here, go easy, this is much harder, right? You take that, right, slow down, Tim, you take that, there's your clue, a double bond from that, straight off. You've got to reduce it to an alcohol, you've got to dehydrate it. Know your stuff. And then what's the crack here? Polymerization, okay, around that double bond, dead easy. Next. There you go, look, doesn't say about that. Chiral centers, again, okay. Alright, so we're talking 1, 2, 3, 4. That's not chiral because there's 2 methyls on it. 4 then. Anything else? That's not chiral, only 3 bonds. You're looking for 3 plus an H. They're easy. You get a feel. C, 4. Another beauty, right? Okay, what clues have I got there? Okay, complete the flow chart. Bromination, right? Bromination, reagents. Nitros, electron withdrawing, aren't they? They are. You need to know that, I think. All right, guys. Electron withdrawing. There it is. Happy days. Sugar BR on because you've got to use halogen carrier to do that if it's electron withdrawing. Reduce to that. There's nothing hard on this paper yet. Nothing. Right? I don't like this, right? Another student carried out the same synthesis, carried out reduction before bromination. So they reduced the NO2 group to an NH2. 2 structural isomers, NH2, top of my head. 2,4 directing, NH2. Not sure how much you've got to remember about this directing. Looks like you've got to remember a bit more than whatever. Think about it. OHs are 2,4,6 directing, phenols 2,4,6. I think, top of my head, an NO2 nitrobenzene is 3 directing, and this tack, NH2, is 2,4 directing. Okay, lost the plot there for a minute. Right, down, 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 down. What's this? How many more is there? Excuse me while I just have a root. Not too bad, bit more to go, but this is a lot of big old paper, a lot in it, lot in it. So we keep going, guys. I know I've overrun my time. What's the question? Cyanide, yeah. Activated in length of carbon chain, 1-chloropropane, yeah. Outline the mechanism, bang, bang. 3 marks for that. Giveaway. Next. This looks cool, right? As soon as I see that, that was what I focused on. I can tell straight away there's a C double bond O. Cyanide goes in as it always does with carbonyls, making the OH. So that's got to come from that. Bangs in there, bangs that. H and H on there. Got to be, remember the H and H on there, it's got to be those, hasn't it, right? There's no other way for it to have an H and H on there. We've met many of them. Right, reaction 2, what we're making? Okay, cyanide, nitriles, they break down. 2 possibilities here, right? Because you can see I'm changing that to CH2NH2. CH2NH2. There, okay? What did I use for that? That's hydrogenation. There. Now I can use hydrogen and nickel for hydrogenating that there to break down into that. So I'm adding a carbon. Beautiful. That carbon's new and I can do stuff now. It's a route from that. So that classic. And that's the other route, HCl. That turns into carboxylic acid, guaranteed. But we'll just have a bit of a check. Yeah. Right, why can it make a salt? Because it's got a nitrogen on it with a lone pair and it's proton acceptor. Okay, there's the structure for salt. Compound I is the monomer for the biodegradable compound J. Draw two repeat units of J and suggest a reason why it's biodegradable. Right, well, where's flipping I? Where? I. Oh, yeah. There's I, guys. There's I. That'll polymerise when it's sweet as a nut there. Right? That joins to another, joins to another. I see a polyester formation here. You draw it out, no problem. There it is, look. Hydrolyzed, okay. Ester bond can be hydrolyzed under acidic conditions, okay. Right, question for you. Show this hydrolyzed under alkaline conditions and show the things that are formed under alkaline conditions. Stop the thing and do it now. Right, next. Which compound secondary amide? I've no idea. Oops-a-daisy. Secondary amide. So we're talking this, aren't we? Do me a favour. On that. Excuse me. R dash. There it is, look. No, because I need an amide link. No amide link here. No amide link here. D. Isn't it? D. Secondary amide. Amide link. Sorted. So I put C down and it's D. Surely. Don't know. I don't know. Right? Any straight chain structural isomers of C7H15Cl contain a chiral carbon atom. You need to know your stuff to do this. Chiral carbon atom, chiral carbon, straight chain, C7, excuse me. I don't know why that says C. No way is that. That's... Oh, it is. Tim, you're a fool. You're a fool. Where have I gone wrong here? Why isn't it D? Right? You should know. Tell me. No answer as usual, right? I don't know what you're doing, right? That's a tertiary amide, you fool. That's a secondary amide. And if that CH3's gone, it'll be a primary amide. Alright? Cool. Next. Right, straight chain structural isomers contain a contain a chiral carbon atom. Blimey, you've got to be fast. What do? 7, 1, 2, 3, 4, 5, 6, 7. Okay, you've got to be straight chain, Cl on the end. So you've got to think aloud here. Cl on the end. Wait a minute, H and H on there, you can forget that. If I put it on there, methyl H load attack, I'll have that. Put it on that carbon there, right, ethyl, butyl H, I'm having that. This baby, oh dear me, because you've got a propyl and a propyl, you've had it. And the rest all go down a nick. I make it 2B. See? You make sure you do that first off, right? Otherwise you're wasting your time. Parents, make sure that the kids have a go at these packs, will you? Before I go through them, because they'll learn much more. That's your job to make sure. And if you tell them otherwise, you tell them. Right, what's the crack? Following can react with compound below to form a carbon-carbon bond. Compound below, bang that in there. CN in ethanol. We've got to watch this. Cover it up. Yeah, that's... watch out, Tim. Watch out, right? Because alkylation Friedel Crafts, that's going to put, I don't know where this directed, a methyl on there. That's a carbon-carbon bond. So, yeah. And that always will do it. That, no. You're going to form an oxygen bond there, not a carbon-carbon bond. It's esterification. So it's them two babies straight on. Okay, 1 and 2, B, yeah. See where I'm coming from? God, how much more of the... Is this a lot? Oh, good. Right, okay. Again, another gold for you, right? Total gold, right? What do you know? What don't you know? I've no idea. Let's have a look. Box there given. This to that. Cyanide, I'm not even looking. Okay, yeah, bangs, bang. Okay, draw it out if you're unclear, you know. Yeah, I want the mechanism. Draw the mechanism out, sharpish, for that CN to attack that carbon delta plus, and jobs are good and to make all that. Okay, dead easy. Excess, that'll break down CH2NH2, there it is, dead easy. Okay, that one there, sodium borehydride, knock it back to a primary alcohol, isn't it? Knock it back, reduce. Reduce is the correct terminology. Back to that, right? This, what's they asking? H plus carboxylic acid, right? End of paper. That's been a bit longer than what I would have hoped for, but enjoy. I'll see you in a minute.